GeopByte.
Look at the another important problem asking like this. A projectile is fired from the surface of the earth with a velocity 5 meter per second and angle theta with the horizontal. From surface of earth, a projectile is projected with a velocity v1 equal to v1 or u1, I can say. Let it be u1. u1 equal to u1 equal to 5 meter per second at an angle theta. Theta 1 equal to theta. Another projectile fired from another planet with a velocity of 3 meter per second and at the same angle in the other planet. Another projectile is projected with a velocity u2 equal to 3 meter per second. Theta 2 equal to theta. Theta 1 equal to theta 2. Theta 1 equal to theta 2 equal to theta. Same angle follows a trajectory which is identical with the trajectory of the projectile fired from the surface. That means trajectory path. The trajectory path remains same, right, for the both projectiles, which are projected. One is from surface of the earth, other is from a particular plane. The value of the acceleration due to gravity on that planet is, let's say, acceleration due to gravity on that planet is g dash. That g dash is how much? But at the surface of the earth, g equal to given 9.8 meter per second square. Okay, as you know, the equation of the equation of the trajectory of a of a projectile y equal to x tan theta minus gx square by 2u square cos theta. That is the equation of trajectory of a projectile. Now here g is variable and u is variable. The remaining all parameters are treated a constant. That means g by u square for earth surface must be equal to g by u square for the planet surface. Planet surface. Here g at that surface is 9.8, u given 5 square equal to, at the planet surface we are assuming g dash by 3 square. Now you simplify it. G dash equal to 9.8 into 3 square 9 divided by 25. You simplify this value for getting around 3.5 meter per second square. That is the acceleration due to gravity on the planet surface. Look at the option A. Option A is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. It is asking like this. The velocity of a projectile at the initial point A is 2i. It is given velocity 2i plus 3j. 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 That is the velocity given. Its velocity at point B. At point A given. Velocity at point B. Velocity at point B. At point B. X component of velocity. X component of velocity remains constant. Remains constant. Only y component of velocity is reversed. Only y component of velocity y component of velocity is reversed. Is reversed. Therefore, velocity at b equal to 2i minus 3j, because velocity y component of velocity is reversing 2i minus 3j. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let's take the another important problem. Okay. Look at the screen. It is asking like this. The horizontal range and the maximum height of a projectile are equal. It is given that the horizontal range and maximum height of a projectile motion remaining equal. The angular projection of the projectile is, what is the angular projection? Okay. For that, we should know the formula for horizontal range and maximum height. Okay. As you know, the horizontal range generally denoted with R equal to U square sine 2 theta divided by G, whereas the maximum height, whereas the maximum height h equal to u square sine square theta by 2g. Okay. As you know, sine 2 theta, let me write it clearly. As you know, sine 2 theta is equal to 2 sine theta cos theta. Therefore, this range can be written as u square into 2 sine theta cos theta dividing by g. Okay. Then let us take the another slide. Let us take the another slide. Here horizontal range R equal to maximum height. Horizontal range, you got 2u square. Let me write it clearly. 2u square sine theta cos theta. 2u square sine theta cos theta divided by g equal to the maximum height equal to u square sine square theta by 2g. Okay. Now let us cancel this u square g and 1 sine theta. 1 sine theta. Then it can be written as 2 cos theta is equal to sine theta divided by 2. Can also be written as 4 cos theta equal to sine theta, or 4 equal to sine theta divided by cos theta. As you know, sine theta by cos theta equal to tan theta. You should know the basic mathematics for solving the problems in the physics. Therefore, this tan theta equal to 4. Therefore, angular projection theta equal to tan inverse tan inverse 4. That is the angular projection. Look at the options. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Look at the screen. It is asking like this. A particle moves in a circle of radius 5 centimeters with a constant speed on a time period of 0.2 pi seconds. Given that radius of circular motion, let it be capital R, 5 centimeters, equal to 5 into 10 power minus 2 meters, because 1 meter equal to 100 centimeters. 100 centimeters. From this, I can write that 1 centimeter equal to 1 by 100 meters equal to 10 power minus 2 meters. Okay. Similarly, the time period. Look at the time period given. time period, generally denoted with capital T, is 0.2 times the phi. The units are seconds. Then the acceleration of the particle. You're asked to decide what is the acceleration. As you know, the acceleration A equal to R omega square. But omega equal to what? Angular speed omega equal to 2 pi by t. It is equal to 2 pi by, look at the t value given, 0.2 pi. 0.2 pi. This pi is cancelled. Pi is cancelled. Finally, it is 2 by 0.2. 2 by 0.2. It is 20 by 2. 20 by 2 is equal to what? 10. 10. Then here R given 5 into 10 power minus 2 into omega. Omega unit is angular speed unit is radians per second. Here it is 10 square. This 10 square, the 10 power minus 2 both are cancelled. Finally, it is 5 meter per second square. Acceleration units is meter per second square. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Look at the screen. Asking like this. A missile is fired for maximum range with initial velocity of 20 meter per second. Given that initial velocity, denoted with u equal to 20 meter per second, and g value given, acceleration due to gravity g equal to 10 meter per second square. The range of the missile, it is given that missile is fired for maximum range. For maximum horizontal range, theta must be equal to 45 degrees. Okay. Then the range maximum, that is maximum range, is equal to u square sine 2 theta divided by g. It is equal to u square by g into sine 2 theta. Sine 2 theta, 2 into 45 degrees. So it is equal to u square. Look at the u square. U 20 square by 10 sine 90. Sine 90 equal to 1. Sine 90 equal to 1. Final it is 20 square, that is 400 divided by 10 equal to 40 meters. That is the maximum horizontal range. Look at the D. Option D is absolutely correct. Understood clearly? Yes.
GeopByte.